Good morning children. In our last video we have already discussed about group 15 elements. Now we are coming to our next topic, that is group 16 elements of this chapter, that is P block elements. So in group 16 these elements are there: oxygen, sulfur, selenium, tellurium and polonium. So for these elements the valence shell electronic configuration is NS2 NP4. That means for oxygen N equals to 2, that is 2s2 2p4. For sulfur the valence electronic configuration will be 3s2 3p4. For selenium it will be 4s2 4p4. For tellurium it will be 5s2 5p4. So just like that. So like nitrogen, oxygen differs from other elements of the group due to the small size and high electronegativity. Nitrogen and oxygen, their properties are different due to their small size and high electronegativity. Now the preparation of oxygen we are coming, that is from the dissociation of potassium chlorate we can get the oxygen gas. Potassium chlorate means 2KClO3. Here the balanced equation is already written. So KClO3 can be broken in, can be dissociated in presence of heat, and here the MnO2 can act, that is manganese dioxide can act as a catalyst, and it will form KCl and oxygen gas. So three stable isotopes we can see for oxygen, that is 16 oxygen, 17 oxygen and 18 oxygen. 16 oxygen, 17, 18, both of the cases they having the same proton number, that is why they are isotope, but their mass numbers are different. 16, 17, 18 are just like that. So next we are coming to that oxygen, where we can use the oxygen gas in our normal respiration and combustion, and also it can be used as an oxidant, like in the liquid state for propelling rockets, in oxyacetylene welding, in the manufacture of many metals like particularly steel. Oxygen cylinder are used in hospital. Already we have seen that oxygen cylinder, it is very much used in hospital and high altitude flying and mountaineering. So of course oxygen it is required for various purpose in our life. So some acidic and basic oxide and amphoteric oxides, we can give some examples. Generally three types of oxide we can get. One is acetic oxide, that is combined with water to give an acid. As for example SO2, Cl2O7, CO2, N2O5, they all are acidic oxides. Why they are acidic oxide? Because when they will combine with water they will form acids. Just like suppose SO2. SO2, when it will combine with H2O, it will form H2SO3, H2SO4. This kind of CO2, carbonic acid will be formed when it will react with water. So each and every acidic oxide, if they can form the acid in presence of water, that means they are called the acidic oxide. Similarly, basic oxide, if they form bases like NaOH, calcium hydroxide, like barium hydroxide, they all are bases because they all having OH minus ions in the solution. They all can donate OH minus ion in the solution. So they all are basic in nature. So when that this kind of oxides like Na2O, CaO, PaO, when they will dissolve in the water, they will react with water, they will form basic bases. So that is why they are called the basic oxide. And amphoteric oxide means they both are having acidic as well as basic oxides in nature. As for example the L2O3 zinc Zn oxide, because they can form that both of the they can react both of the acid as well as bases, and they can form the salt and water. Okay, so they all are called amphoteric oxide. And one more oxides are there, that is neutral oxide. Generally 4 oxides we can get in our nature, not 3, it is 4. So neutral oxides are, they are neither basic or nor acidic. That means they cannot give any acid or bases in presence of water. That is, as for example CO, NO, N2O, just like that. And ozone is an allotropic form of oxygen. It is a powerful oxidizing agent. Ozone is a powerful oxidizing agent and it is one allotropic form of oxygen. Why ozone is powerful oxidizing agent? Because ozone can form nascent oxygen. Nascent oxygen means the free radical of the oxygen atom. So free radical means it will be very much reactive. It should want to react with another element. So that is why this is a very good reacting agent. So it is very reactive. So that is why ozone is a very good powerful oxidizing agent, because it can oxidize the other. Whenever oxygen will be attached with another element, so obviously it will be oxidized. So that is why. Next, sulfur we are coming. Various allotropic form of sulfur we can see. Rhombic sulfur, monoclinic sulfur, one of them, and both rhombic and monoclinic sulfur, they can exist in the nature generally is in terms of S8 molecule. It is generally sulfur forms a giant molecule, that is S8 molecule. And various oxides of sulfur we can see, that sulfur dioxide, sulfur trioxide, SO2, SO3 both. Okay. So now we are coming to sulfur dioxide. So in laboratory, sulfur dioxide is prepared by treating sulfides of active metal with dilute sulfuric acid. When active metal it reacts with dilute sulfuric acid, then sulfur dioxide will be produced. It causes headache when inhaled in small amount, while it might prove fatal in large amount. Okay. It is pungent smelling gas which is soluble in water. The properties of the sulfur dioxide I am saying about, it is heavier than air and its boiling point is 263 Kelvin. And it is neither combustible nor does it support combustion. Also, it has both acidic and bleaching properties. Sulfur dioxide, when it dissolves in water, it will make H2SO3, and this is an acid, and also it can be used as bleaching properties. For our bleaching properties, we can use the sulfur dioxide as well. Okay. And next, it reacts with alkalis such as sodium hydroxide. When sulfur is present in limited amount, it forms their respective soluble sulfides and water. But when sulfur is present in excess amount, it forms respective metal hydrogen sulfide. So when sulfur is present in limited amount, that time we are getting soluble sulfides and water. But when sulfur is present in excess amount, then it will form metal hydrogen sulfides. I think all of you can understand up to this. Next property, it can reduce chlorine water to hydrochloric acid. So that means when SO2 plus HCl, Cl2, it will be reacted with water, then hydrochloric acid will be formed, and sulfuryl chloride with dry chlorine gas, it will be formed. So moist sulfur dioxide behaves as a reducing agent. Why sulfur dioxide is a good reducing agent? Because in sulfur dioxide, sulfur is present in +4 oxidation state, but maximum oxidation state of sulfur, it is +6. So sulfur can oxidize itself by increasing the oxidation number from +4 to +6. As it can increase its oxidation number from +4 to +6, so that means it can oxidize itself. So that means it can reduce another. So as it can reduce another by getting itself oxidized, so that is why it is a good reducing agent. So next, very common substance of sulfur, that is sulfuric acid. We know about sulfuric acid. Concentrated sulfuric acid is known as oil of vitriol. It occurs in free state in hot water of sulfur springs. In combined state, it occurs in mineral sulfates. Sulfuric acid is prepared by contact process. It involves burning of pure and dry mixture of 2 parts of sulfur or sulfide ores and 1 part of the air in presence of vanadium pentoxide, that is V2O5, or asbestos as a catalyst. Okay. Now, chemical reaction of H2SO4 are because of its very low volatility, strong acidic character. They are very non-volatile type of nature it is having. They are having very strong acidic character, because we know sulfuric acid is a very strong acid. Strong affinity for water. It is a if we keep some sulfuric acid in some amount of water, we can see the sulfuric acid easily dissolved in the water, and ability to act as an oxidizing agent, because in sulfuric acid sulfur is present in +6 oxidation state, and it is the maximum oxidation state of the sulfur. So it cannot increase its oxidation state. So it cannot oxidize itself, but it can reduce itself, because +4 oxidation state, +2 oxidation state, -2 oxidation state are also possible for sulfur. So it can be reduced itself, but it can oxidize another. So that means it is a good oxidizing agent. So dilute sulfuric acid reacts with active metal like Zn plus H2SO4, ZnSO4 plus H2, then hydrogen gas will be produced, metal oxide, metal hydroxide, metal carbonates, metal sulfides to form respective metal sulfates and acid sulfates. Because of low volatility, it can be used for the manufacture of more volatile acids from their corresponding salts. And it is a strong dehydrating agent because of its strong affinity of water. It has very good affinity towards the water, and sulfuric acid removes water from hydrated salt and organic compounds. Concentrated sulfuric acid is moderately strong oxidizing agent and can oxidize both metals and non-metals. Concentrated sulfuric acid, it can be used as strong oxidizing agent and can oxidize both metals and non-metals. Okay, so all of you can understand these points. So these are the main points of group 16, and from group 16 these type of questions may come, like from the classification of the elements that we already this chapter we have done in class 11. So some concept from there also it may come, why H2SO4 can act as a good oxidizing agent. If we come from top to bottom in a group, then what will be the change of electronegativity. So these kind of questions also may come from physical properties and chemical properties. For both of the cases the question may come. So I think all of you can understand. In our next video we will discuss group 17 and group 18. Thank you.